Good afternoon, everyone. Thank you for taking the time to tune in. My name is Jose Etchart, and today I will present on one of my thesis chapters titled Evaluating Water Use of Desert Bighorn Sheep and Aoudad in the Sierra Vieja Mountains, Texas. I'd like to start with a little bit of background information pertaining to both species in Texas. So in the late 1800s, there was an estimated population of 1,500 desert bighorn inhabiting 16 mountain ranges in the Trans-Pecos region. The dotted line in this map depicts the historical ranges. By the 1960s, the desert bighorn sheep population was extirpated. Causes of this decline were attributed to a series of combinations of the following factors: unregulated hunting, the introduction of domestic sheep and goats, and the diseases that were brought with them, as well as the implementation of net wire fencing in desert bighorn sheep habitat, causing fragmentation in the landscape. Due to these declines, restoration efforts began in 1957 by the reintroduction of desert bighorn from Arizona, Nevada, Utah, and Baja California, Mexico. Decades of translocation efforts have taken place, with 53 events reported, and is the reason populations exist in the state today. Since 2010, 477 desert bighorn have been translocated in-state to 11 of the 16 historical mountain ranges, with 2019 population surveys estimating 1,500 desert bighorn. As these translocation efforts continue, several challenges are faced, either biologically, sociologically, and politically. Currently, these efforts are being challenged by trying to identify historical mountain ranges in which aoudad and exotic is not present. Here, this map shows the current desert bighorn sheep ranges to date, with our focus right now and trying to move forward with our restoration. It's in between the Sierra Vieja Mountains and the Big Bend Ranch State Park. So this mountain range right here. And this is where I'll be talking about some of the findings that we're seeing on just the high abundance of aoudad in that particular area. So exotic species on the landscape has become a severe issue in conservation ecology. Past literature has identified potential detrimental effects as competition to native species, alterations in community structure, biodiversity, and invasion-mediated extinction to native species, which raises concerns in the conservation efforts of desert bighorn in Texas. The introduction and release of aoudad is now well documented. Anecdotal reports take it back to 1940s with private introductions into high fence ranches. But truly, the first known free-range introduction occurred in 1957, where 44 aoudad were released in Paladuro Canyon in the Texas Panhandle. In 1988, Charwick and Welch reported a total of 20,402 aoudad in Texas. They were found in 159 ranches in 65 counties and free-ranging in 8 additional counties. Current populations are unknown, but anecdotal report from landowners, hunters, and biologists suggests an increase in range expansion of aoudad throughout the Trans-Pecos. A recent survey in a potential restoration area for desert bighorn estimated a total of 5,000 aoudad. With this in mind, the need to gain baseline knowledge of the species is empirical for the future of the desert bighorn conservation in Texas. And with that, I'll go ahead and jump into my water chapter. So in the arid regions of the Southwest, water is considered a limited resource for wildlife. Due to the lack of water in the landscape, the implementation of artificial water sources has become a popular management tool in the management of wildlife species. So what is an artificial water source? An artificial water source is any man-made water catchment. There are several different types of artificial water sources, and each vary by the way they get water. In the last century, 11 Western wildlife agencies have implemented approximately 6,000 artificial water sources and spend more than $1 million a year for the implementation of this practice. Since the 1940s, artificial water sources has become a general management tool for the restoration of desert bighorn sheep. Debate exists regarding desert bighorn water use, as literature shows that desert bighorn can go for long periods of time with no water. The importance of water for desert bighorn is not conclusive, but the need to continue monitoring the use of artificial water sources could provide knowledge if at any point this practice could potentially affect desert bighorn sheep negatively, as utilization of artificial water use occurs by aoudad. Furthermore, potential competition for this resource could affect the native species, and potentially artificial water sources will serve as a disease risk transmission site between natives and exotics. The objectives of this study were to conduct a descriptive study of the use of artificial water sources in a restoration area where desert bighorn and aoudad inhabit, document the seasonal and temporal use of artificial water sources by both species, and document lambing presence at artificial water sources. The study was conducted on a private ranch in the Sierra Vieja Mountains. Elevations range from 1,500 to 1,900 meters. It is found in the Chihuahuan Desert ecoregion. The annual rainfall averages between 35 to 3,800 millimeters per year, with a monsoon rainfall pattern. And the average temperatures range from 32 to 34 degrees Celsius in the summer and 15 to 18 degrees Celsius in the winter. Data collection started from June 2014 to February 2017. Game cameras were placed at 9 artificial water sources by mounting them on a T-post approximately 1 meter off the ground. They were programmed to take a 2-picture burst and were set to a 5-minute delay after each burst. Cameras were checked every 2 weeks for battery life and SD card storage, and then sorted by location, species, and number of individuals. For analysis purposes, 3 game camera analysis programs were used, created by Dr. Jim Sanderson. Renamer Light was used to change the format name of each photo to the date and time the picture was taken. Data Organize was used to organize the photos in different folders and create folder paths for program data analyzed, which this program provided our analysis output. For the duration and lamb presence at water analysis, I used photos from June 2014 through June 2016 to better assess and capture 2 full potential lambing seasons. 2 criteria were used in classifying lambs. First one being in identifying individuals half the height of an adult desert bighorn or aoudad present, and identifying individuals with horn length less than ear length. According to Gray and Simpson, these criteria would determine the age of a 0 to a 4.5-month-old lamb. For my results, a total of 7,955 camera trap days were observed, with a total of 41,069 photos used for analysis, documenting 27 wildlife species using the water sources. These are the 28 species documented using the water sources. As you can see, mule deer were documented the most, followed by aoudad coming in second and white-tailed deer coming in third. Desert bighorn sheep ranked 10th overall. In this graph, you can see the use of the 9 artificial water sources by both species, with desert bighorn utilizing 8 of the 9 water sources and aoudad utilizing all 9. It is worth mentioning that desert bighorn were not documented using E6, since this was the furthest southern water from where the desert bighorn were released, so expansion may not have occurred yet at the time of this study. So in this graph, we can see desert bighorn and aoudad utilization overlaid by the series of precipitation events throughout the study area. Both species tended to increase water use in the late spring and summer months. Desert bighorn sheep water utilization decreased or was non-existent in some of the winter months, while for aoudad, utilization was documented throughout all months of the study period. Aoudad utilization seemed to be more dependent to precipitation events than desert bighorn sheep, and desert bighorn seemed to be more influenced by temperature than precipitation. In this next graph, we can see the same information for both species overlaid by the monthly mean temperatures. And pretty similar to the precipitation, as you can see, once the high temperatures rise, the more utilization occurs by both species. In this slide, we'll see the DO usage of both species, and desert bighorn presence was observed throughout the middle of the day, while aoudad experienced a crepuscular activity water use. Lamb presence for both species was recorded in the late spring and early summer months. Something that was really distinctive here was that aoudad lambs were also observed in the fall and winter months, which could potentially reflect a second lambing peak occurring in the fall months. For time spent at artificial water sources Duration at water sources reflects a similar comparison between both species. As the average number of individuals increase, the time spent at water sources increases as well. I would like to point out the larger average number of individuals in aoudad herd sizes in comparison to desert bighorn sheep. Jumping into my discussion, desert bighorn sheep used artificial water sources on a seasonal basis, with summer months being highest in utilization and significantly decreasing activity in the winter months. My findings concur with Foster et al. In 2005 in the Black Gap Wildlife Management Area here in Texas. Desert bighorn sheep water usage was seasonal and increased when temperatures and evapotranspiration increased. Similar results were reported in Harris et al., as 70% of all desert bighorn sheep visits to water sources occurred from April through August in the Chihuahuan Desert. Aoudad expressed similar seasonal water utilization months as desert bighorn, but the presence was generalized throughout all months. This could potentially correlate to a larger population size of aoudad in the mountain range, or exhibit the generalist behavior of aoudad on resources available. Additionally, lactation requirements may impose additional water requirements on aoudad throughout the fall months going into the winter. Deal use of artificial water sources by both species differed. Desert bighorn sheep use of artificial water sources primarily occurred during afternoon hours and lacked the crepuscular activity patterns observed in aoudad water use. My findings differ from past studies, which indicated crepuscular water activity by desert bighorn sheep. These comparisons raise questions in Texas, since all the study areas with desert bighorn water use has been monitored, aoudad have been present. Exotic species have been pointed out as potentially affecting the water use of desert bighorn sheep by Osterman, Kelm et al. In 2008, which could potentially explain the deal use activity patterns for aoudad and desert bighorn in my study. Time spent on artificial water sources for those species increased as the number of individuals per detection event increased. In past studies, desert bighorn generally remain at water sources less than 5 minutes. In this study, I found that most desert bighorn events occurred in periods of less than 5 minutes, and aoudad exhibited similar results. However, the capability of aoudad developing larger herd sizes raises concerns as more prolonged periods around artificial water sources were observed. And this could be attributed to some of the behavior that aoudad expressed, like loafing, dust bathing, mud bathing, and bedding near water sources. Furthermore, detection of desert bighorn sheep lambs were primarily in the late spring to late summer months, reflecting the spring lambing period. Aoudad lamb peak presence or artificial water sources occurred in the early spring and early summer months. My study reflects the lactation requirements for both species, as lambs were observed following the lambing period. However, aoudad lamb presence at water sources in the fall and winter months suggest a potential second lambing period. These findings may also support aoudad continuous general utilization of artificial water sources throughout the year. Peak breeding season in this population occurs in the fall months, from September to November, which is similar to Ogren's study in New Mexico in 1965. Future research should determine artificial water use by sex for each species to determine if aoudad utilized water throughout the year in a more generalized fashion due to lactation. Consequently, incorporating tagged individuals and identifying these individuals' lambing events can help determine if one ewe can lamb twice a year or if this idea is dependent on age. With that, I'll jump into my management implications. I would like to say that caution is advised when using artificial water for desert bighorn sheep restoration in areas where aoudad inhabit. The implementation could increase the likelihood of desert bighorn and aoudad coming into proximity, increasing the probabilities of disease transmission and possible resource competition. My results suggest a possible water management plan in which artificial water sources could be active in certain times of the year according to the target species. In terms of desert bighorn, the summer months would be a crucial time of the year to provide water. In areas where artificial water sources depend on precipitation events to maintain waters active, the frequent utilization of water by aoudad year-round can potentially affect water availability when needed in the summer months for desert bighorn or other native wildlife. As aoudad control techniques are evaluated to try to keep population in check in the Trans-Pecos, my results can provide strategic methods of conducting aoudad control by using waters as an advantage in certain times of the year. First and foremost, I would like to thank God for giving me the opportunity to study these amazing animals and be out in their landscape, as well as all of my committee members that were part of guiding me through this whole process of trying to get my master's done. Also, for Lon Hernandez, our Texas Parks and Wildlife Desert Bighorn Sheep Program leader, for mentoring me along the way from career-wise to my master's project. And I would also like to thank the White family for their hospitality and access to the Bright Ranch. My two technicians, Severio Avila and Destiny Love, for all their time spent sorting through all those wildlife pictures, and my family and fellow BRI graduate students. I couldn't have done it without y'all. Thank you. And at this point, I'm open to any questions. Thank y'all.